Hello, everyone. Thank you very much for taking part of this session. My name is Nicolas Martin, and I'm in the Illinois University. And I am going to talk with you about the alignment of spatial information using R. And this is a very important topic because very often many researchers that work in this area find many difficulties. So we are going to give you a few instructions on how to deal with these topics. The other thing is that uh, based on there's going to be a few grammar mistakes and a few words that are going to be mixed here, that are going to be filtered from Spanish to English. So I'm going to ask you um, to not pay attention to that. I hope that this is a very useful topic for you. Now we're going to show you the different topics: projections, image extracting, sampling, spatial joins, spatial alignment of data. And by the end of this session, we are going to show you some of the criterions that we are using to work with this data. So initially, we are going to talk about absent data, when they're unbalanced. But generally, one of the most subtle ways to compensate that would be by using some of these methods, and also how the data is assembled. This can have consequences on the analysis that you're going to carry out. So let's begin with this. And before continuing, I would like to tell you about two important sources. The first one would be the GeoComputation book, and the other one, let me open it here. This is another book that has many resources, many codes, and it's being currently updated. So it's a very interesting source. I would recommend it to you so that you can read it and you can use it. I want to show you other auxiliary material. This is another book that we also use here in class, and it's called the Spatial Data Analysis for Agriculture using R. And it has different topics applied to natural resources in agriculture that can be of interest. And clearly, this has a lot more detail, and it also offers a great amount of content and text that can be very useful. You also have other links to other tutorials for spatial analysis. So this is another link that you can visit. So the main objective of this tutorial is to cover a common topic in spatial data analysis, like how to assemble data from different formats and different supports and scales. So that's the main objective for this session. And the first topic that we're going to talk about would be projections. So normally, this is a critical topic because data can have different projections depending on the source. So uh, the source determines the different formats, the spatial formats, and if data is different and you want to combine them and they have different projections, the alignment is not going to work properly. So we're going to talk about this. And the use of projections allows to convert a three-dimensional spheroid into a two-dimensional plane. If the data that we want to align have different projections, it's going to be difficult to achieve this and also use them together. So the first part is critical. When people use different projections, what they're trying to do is to convert a spheroid into a plane. So when this happens, there are several things that have to be taken into account, different angles. The first one is you want to preserve the area, if you want to preserve the directions or the shape. So there are some projections, like for example, this one that's called WGS, a World Geodetic System, that's often used for maps, online maps. And this is used mostly for navigation, and it's also used for directions and for instructions on how to get from one place to another. So the direction is properly preserved, but as you know, the area is very different. So I'm going to show you a very fun example. This is an example of a map of the US where they first use an example with WGS 84. And on the side, there's another example using or showing how it would look with another type of projection that covers the area better and also the shape, but the directions are distorted. So everything that should be in the straight line isn't. And this is used very often too. Something else that's important is how the dimensions and the sizes change. And I'm going to show you this example with a tool. With this tool, you can choose a country and move it from one place to another. So let's say that I'm going to choose Mexico. And you can see it's relatively small. And I move it. You can see that the size, it's a lot larger. And this happens because of the sort of projection that is being used. Sometimes you have you perceive a certain dimension, but things aren't that size in reality. So this is very interesting. It's something that I would like for you to bear in mind if you want to use it. When there's another type of projection that are UTM or Universal Transverse Mercator, they measure the distances in meters with small distortions. The main constraint that it works for small areas. So usually you have to define if let's say there are sections like north and south, and after that you have to allocate the corresponding segment, and in that segment everything is preserved, the shape, the direction, and the distances. So for example, in Illinois, we have the north 16, but it's probably in a region in Mexico, it's going to be north 14. Or if it's in South America, you can use the south 20. So you have to specify that in order to do changes. To do changes in projection in R, there's one of the files and one of the programs for performing those changes by using the SP format, the SP package. You need to specify a CRS that's been previously defined. So this is called coordinate reference system. And with a number, you can also specify it with a number. So there are some codes that instead of saying WGS, you can use this code, which is 4238. So these are conventions, and they allow to assign um, the coordinates to a data set, the defined projection, And it can also be used to change or transform the coordinate system from one to another. So those projections can be changed by changing the CRS. And these are the different codes that you can use to do those changes. And if they're disaligned, they're not aligned, you're not going to have any problems so that you can work afterwards. So this is what you have to do from the beginning. So this is what I had for you to begin this conversation, this module about changes in the projections.